Hey there, Year 9s, Mr. Herman here. This is exercise 7c, sketching parabolas using factorization. Learning goals for this lesson is to know the steps for sketching a quadratic graph in the form of y equals x squared plus bx plus c, and to understand that quadratic graphs can have 0, 1, or 2 x-intercepts, depending on what type of scenario you're put into. The success criteria for this lesson is to know how to use factorization to determine the x-intercepts of a quadratic graph and to know how to use symmetry to locate the turning point once the x-intercepts are known. So sketching parabolas using factorization, when we have a quadratic relation written in the form of y equals x squared plus bx plus c, this differs to what we were used to from the previous exercise, which was y is equal to, and we had this bracket notation of x minus h or x plus h, depends on what type of scenario you've been given. We have a constant outside the front. This dilates the graph, and then we have this other k that's added or subtracted at the end, and that shifts it up or down with this shift in left or right. But when you have it in this format here, it's not as obvious to know what type of shift or movement or dilation is happening with the graph. So it's less obvious. It's less obvious to know what the change is. And so to address this, we have a number of options. The first one is to factorize to find excuse me, the x-intercepts. So factorize it, so get in this format here into the format where y equals x plus minus something, x plus minus something. We can have it in this format. And then we use what's called symmetry to find the turning point. That's the first option we could do. Alternatively, we can complete this square and express the quadratic relation in turning point form. And the second method, the latter, this is the one we're going to study in the next section, in the next part. In other words, when we have a y equals x squared plus bx plus c, these are the four main, three main points of interest that we have. The x-intercepts, which we can get by using the Null Factor Law by factorizing. The Y-intercept by substituting x equals 0 into the formula. And the turning point by finding these 2 points of the x-intercepts and then finding the middle of this point. And there's a method behind every single process. The x-intercepts and the y-intercepts you've seen before from previous exercises in the previous topic. The turning point will be something new, but it's relatively simple. So to sketch the graph of a y equals x squared plus bx plus c, now we're not dealing with an a x squared, we're not necessarily dealing with a coefficient in front of the x squared for now anyways. So what we first do is, the first step is we find the y-intercept. So the y-intercept, remember the y-intercept is when we have a graph that looks like this. The part of the parabola that hits this y line. Now this can happen below the x-axis or on top, but it will only hit once, and it will either hit in the center or on the right hand side from the graph, or the left hand side, depending on what type of shift you have. It will always hit the y-intercept once. And this happens when you just substitute x equals 0 into whatever equation you got. And then after that, you're going to find the x-intercepts, and you do this by substituting y is equal to 0. And then you factorize where possible. If you can factorize it, go ahead and factorize it. And then you use the Null Factor Law. So when you have it in this form, x plus a, x plus b, and this is equal to 0, use your Null Factor Law to say either this is equal to 0 or this is equal to 0, and then you work out what the x values could be. And once you get those x values, they will determine what your x-intercepts will be. Now, you could either hit a scenario where you have 0, 1, or 2 x-intercepts. This happens when, if you want to look at it visually, 3 different types of scenarios happens. If it hits the x-intercept once, or there's only one, the turning point will be on the x-intercept itself. This is when there's only one solution. When there's 2, the x will cut 2 parts or the line, sorry, will cut two parts of the X axis. That happens when the shift is pushed down or pushed up, depending on if it's inverted. And the other scenario, when there's no X-intercept, is when you have a graph that could either look like that or like that, and there's no touch of the X-intercept, which is this here. So these are the different types of scenarios that you'll get. Once you've done that, once the X-intercepts are known, the turning point can be found using what we call symmetry. And this is really simple. The axis of symmetry, it lies halfway between the two X-intercepts. So in this scenario here, they've got the X-intercept as 1 and 5. To find what this halfway point is, you find the distance in between here, and then you split that in half. Okay. Another way of doing this is get your first X-intercept, get your second one, add them, and then divide that. So this is saying that the X coordinate for where the halfway line and where the turning point will happen when X is equal to 3. And then once you've got the X coordinate, you substitute this 3 back into the original equation, and that will give you the Y coordinate of the turning point. So these are all the rules, these are all the steps. Obviously this will run a bit better if we actually apply it to some examples. Alright, let's have a look. Sketch the graph of the following quadratics by using the X-intercepts to help determine the coordinates of the turning point. So the first thing we're going to do for A, we have y equals x squared minus 2x. You notice there's no plus or minus some constant that's by itself tagging towards the end. And that's going to make a difference to how this graph is going to look. Now we're going to look for the y-intercept. So the y-intercept happens when x is equal to 0. X is equal to 0. So what we're going to do is we're going to substitute 0 into this formula. So we've got y equals 0 squared minus 2 times 0. 0 squared is 0. 2 times 0 is 0. 0 minus 0. Y is equal to 0. So at 0, 0, that's where the y-intercept is going to hit. So for now, we know at some point, something's going to happen there at 0, 0. Okay, we need more information. Now let's look for the X-intercept. The X-intercept is going to happen when y is equal to 0. So when y is equal to 0, let's put in our x squared minus 2x is equal to 0. We can factorize this. We can take out x as a common factor, and what we'll be left with is x minus 2. And this is equal to 0. And we can use our Null Factor Law to suggest that either this is equal to 0 or x minus 2 is equal to 0. So we can say from here that x is equal to 0 or x minus 2 is equal to 0 in order for this equation rather here to suffice. And for this to work, we're going to plus 2 to both sides to get x by itself. And so we have x is equal to 2. So this scenario, there are two scenarios where in order for this to work, x can take on the value of 0, because 0 times negative 2 will give me 0, or when x is equal to 2, 2 times 0, that will give me 0 as well. So these are the two options that work. So this point here would then be 0, 0, and this point here will be 2, 0. So now we found these x coordinates, or in other words, if we go back up to this rough graph, we've already got this 0, 0 here for our y-intercept, so we know the x-intercept is obviously the same thing. But we've also got another one where it happens at 2, 0, when x is equal to 2, which is here, y is equal to 0. That's 1, that's 2. Now, this is just really rough. This I use as a guide to try to determine what this graph is actually going to look like. So far we've got this x, we've got these two x coordinates here. These are going to be our x intercepts, and we know we're dealing with a graph that doesn't have a negative in front of the x squared. So far we're going to deal with something roughly that looks like this. And now the last thing we're going to look for is that point there, this turning point. let's try to look for what this turning point is. And this is where we use that symmetry in order to get it. Now, we've got our two x coordinates. We've got it at when x is equal to 0, when x is equal to 0, and when x is equal to 2. Now we can tell straight away that obviously the x coordinate for our symmetry, our line of symmetry, happens in between 0 and 2, and this will be at 1. Let's just use our formula. This is going to be equal to 0 plus 2 divided by 2, which is 2 over 2, which is equal to 1. So we know that our symmetry is going to happen at x is equal to 1. What we don't know is what the corresponding y value will be for this. In order to determine that, we substitute this x value of 1 into the formula of y equals x squared minus 2x, the original formula. So I'm just going to say sub in x equals 1. So y is equal to 1 squared minus 2 times 1. So this here is going to be equal to 1 minus 2, which is equal to negative 2. And we're kind of expecting a negative y value. So this turning point right here is 1, negative 2. And the y has to, the y coordinate of that has to dip down somewhere, and this will happen at negative 2. And this is where you can tell I'm obviously doing this late at night. 1 minus 2 is negative 1. Oops. So let's get back to this here. There you go. So that there is negative 1. This here is negative 1. Obviously, negative 1, not negative 2, doesn't make sense. So this y coordinate, corresponding y coordinate happens at negative 1. So x equals 1, y equals negative 1. There we go. This right here is the better representation of the graph. So there's your x and y intercept. There's the second x-intercept. There's a turning point, and it is just your normal upright parabola. And that sketched, this is a proper sketched version of what you're getting. So you're obtaining this point, and then your turning point. Gosh, apologies for that mix-up. All right, second one, we have a y is equal to x squared minus 6x plus 5. So the first thing we're going to do again is we're going to work out what our y-intercepts are, and this is when x is equal to 0. So to get our y-intercepts, when x is equal to 0, and this is a straight simple substitution into here, y is equal to 0 squared minus 6 times 0 plus 5. And you can see that when there's when we're trying to find a y-intercept, it just namely is what this thing tagged along at the end is. So this is equal to 0 minus 6 times 0, which is 0, plus 5, this is 5. So at 0, 5, we have a y-intercept. So that happens when x is equal to 0, 1, 2, 3, 4, 5 roughly. We're going to have a point here. Because this is upright, we're expecting something like either this to happen or that to happen. We need a bit more information. Okay, now let's look for the x-intercept. The x-intercept happens when y is equal to 0. When y is equal to 0. So we have this x squared minus 6x plus 5 is equal to 0. Now, we've got an array of options that we can use to try to determine what the corresponding x value or x values could be in order to get this to equal to 0. I'm going to factorize this. I'm going to find two numbers that when multiplied together will give me positive 5, and then when added together will give me negative 6. These two numbers are negative 5 and negative 1. Negative 5 and negative 1. Negative 5 times negative 1 gives me positive 5, and negative 5 plus minus 1, so negative 5 minus 1 gives me negative 6. So these are the two values that we can use to factorize this in order to make this equal to 0, and then we'll use our Null Factor Law to state that either x minus 5 is equal to 0 or x minus 1 is equal to 0. Try that again. So x can either equal 5 or x can either equal 1. So we're 2 points, 5, 0 or 1, 0. These are the 2 points of the 2 x-intercepts that will happen at 1, 0 or 5, 0. So 1, 0 being here and 5, 0 being here. There's our x-coordinates or x-intercepts. So we're expecting the graph roughly to look like that. And now what we're going to do is just find that turning point. And so we've got our formula already to get a turning point. It's the 2 x coordinates and then divide by 2. When I try to get that, the x turning point, I always put the lowest number first and then add the highest number. So this is 6 over 2, which is equal to 3. So a 3 is the x coordinate. But that happens for this, and then we're going to substitute that 3 into the x squared minus 6x plus 5 formula in order to get what our corresponding y value is in order to get the turning point. You can substitute it in either this or the second one. I'm going to substitute it into the second one because it's already in a nice format. So to get the corresponding y turning point, I'm going to write this over here. This is just 3 minus 5, 3 minus 1. So 3 minus 5 is negative 2 multiplied by 3 minus 1, which is 2. And this is equal to negative 4. To get a better representation of this, here we have a proper graph. That's the y-intercept. These are the 2 x-intercepts. And there's a turning point, the 3, negative 4, the 3, negative 4, which is what we got here, corresponding 3 over here, and then the 4 for the corresponding 3 when substituted into the formula, and that's our turning point here. Last example, we're going to sketch this perfect square. We're going to sketch the graph of the quadratic y equals x squared plus 6x plus 9. Okay, firstly, let's get our y-intercept when x is equal to 0. So y-int when x is equal to 0, we're going to substitute 0 into here. Y equals 0 squared plus 6, 0 plus 9, and this, by now you should know, 0 plus 9 is equal to 9. So our first coordinate we have is somewhere around here. That is at 9. That's where our our y-interceptors are going to happen. And we don't know if we're going to have a graph that is going to look like that or like that. Alright, x-intercept. And this is when y is equal to 0. So we're going to substitute x squared plus 6x plus 9 is equal to 0. We can go ahead and factorize this. We'll just get rid of that graph. So we can go ahead and now it says in the question this is a perfect square. So automatically I know this is x plus 3 squared because I'm looking for 2 numbers that when multiplied will give me 9 and then when added will give me 6, and this is both 3 and 3. So this will be x plus 3 or x plus 3 squared. Now, we've already seen this in this format. We know for a fact that when it's in the square, whatever this is, if it's a plus, it gets shifted to the left 3 units, or however many units, whatever the number is. So what we need to do is to solve for this. If I square both sides, square root, sorry, both sides, I end up getting x plus 3 is equal to 0, x is equal to negative 3. And there's only one coordinate. There's only one coordinate where this works. And this is that x is equal to negative 3. So negative 3, 0. So negative 3, 0 happens around here. there's no other x coordinate that will take an intercept. There is only one. There is only one. And when there is only one, I know for a fact that that there will be my turning point. So my graph is going to look like this. And because we know this, because it's taken this format and this gets shifted to the left 3 times, it doesn't get pushed up or down or anything. It just looks like that. So that right there is a proper representation of the graph of x squared plus 6x plus 9. Alright guys, that is the last example. You're going to go ahead and you're going to attempt the questions that we have here. So questions from exercise 7c, yeah, keyboard, let's tackle the keyboard, go away. 1a, 2ad, 3ade, 4ac, 5a, and 6a as an extension if you want to attempt it. Go away. Remember, this is going to be the first lesson remote, so lesson 1, which is Monday, which is the video that you're watching now, but then lesson 2 and lesson 3 will be in class. You're going to continue on with exercise 7D within class, so you've only got this one day to attempt 7C. Best of luck guys, and I'll see you tomorrow in class.